What's inside a hard drive? Today we're going to be tearing one of these apart and taking a look at what's inside, the basic principles of operation, and if there's anything we can scavenge for our own DIY projects. Welcome to the House of Hacks. If you're new here, I'm Harley, and I make stuff. Usually with wood or metal or other things of that nature, but sometimes I like taking things apart to see how they work so I can get inspired for my own ideas and also find materials that I might be able to repurpose for other projects. Today we're going to be taking a look at hard drives, what's inside them. I've got some old hard drives here. These date from the late 90s. These happen to be made by Quantum and they're Fireball model drives. They were manufactured 96 to 97, was kind of the heyday of when these came out. These are 1 gigabyte or 2 gigabyte drives, depending on the particular model you got. We've come a long way now that most drives are rated as terabytes. They're 1,000 times bigger and usually much smaller than these were. But the interesting thing about hard drives is the fundamental principles of them haven't really changed since they were first invented. The sizes have shrunk dramatically, the density of the data has increased dramatically, but the fundamental principles of how they work really remain the same even up to today's hard drives. Basically, a hard drive is a metal box with some spinning disks inside and a controller on the outside. I'm going to basically strip this down and we can take a look at the various component parts of this. Depending on the model and the manufacturer, they may have different types of screws. Some of them have hex screws, some of them have Torx screws. This one happens to have Phillips screws before they started going to the quote-unquote higher security model. So I'm going to just start pulling this apart and talking about what's going on here. The controller board on the outside is what's responsible for keeping track of where things are on the hard drive itself. Everything is recorded magnetically, and that magnetic format at the lowest level is controlled by these controllers. There's another level of formatting that's on top of that that is handled by the operating system, and it controls what files are where, the directory layout, things of that nature. But the actual work of converting the magnetic impulses on the hard drive to ones and zeros for the computer are taken care of by these controllers. The controllers also have an interface to the computer, and depending on the age of the computer, at the age of the drive, and what's in vogue at the time, you may have different types of interfaces. These happen to be SCSI interfaces. New drives usually have SATA interfaces. There are a number of different types of interfaces over the years as technology has improved. So this is what the controller looks like. It's basically just a circuit board. Over the years, these have gotten smaller and faster. It's all very customized circuitry on here. There's really not a whole lot that we could scavenge off this if we wanted to. Perhaps some resistors, but it's all surface mount stuff, so it's kind of hard to use. You might be able to take some of these connectors off for other projects though. On the other side of the drive, we have a cover plate, and these are usually held on by a number of screws. We need the larger screwdriver here. In this case, there are 6 screws that hold this on. And when you open this, you void the warranty. This is a sealed unit that is put together in a clean room, so it's very clean inside. The tolerances that are used inside these hard drives are so small that just a very, very fine bit of dirt inside would cause havoc with scratching the surface of the drives. So there's usually tape or some sort of sealer around the edges also to keep the dirt and other contaminants out of the drives. Let me get a bigger screwdriver. Oh, you know what? I bet there's another screw underneath here. Warranty void if seal broken. And of course that happens to be a Torx screw. There we go. There we go. Feels like there's another screw under this seal also. They like to hide these screws. I guess they really don't want you taking them apart. Oh, man, that one's awful tight too. That one has a nut on it. Worried about pinching myself here if I slip. And it doesn't really have a good grip on it. Oh, there it goes. Needle nose for the win. That feels better. Success! So this is just a metal plate with sealant all around the edges. Nothing super special about it. This is what the inside looks like. So every drive I've ever had open is basically the same thing. We've got the chassis here, typically made out of some sort of aluminum alloy. We've got the electronics coming from the controller board that's mounted on the outside, going through this ribbon cable that goes to this armature. On one side of this armature, we have read-write heads, and some of the electronic circuitry goes to these to write and read data from the platters right here. These platters have a magnetic material on them that will, kind of like a tape recorder, that will record permanently magnetic flux that can be interpreted as either a 1 or a 0. At the other end of this armature over here, there's a pivot point here. On the other end, there's these very strong rare earth magnets that provide a magnetic field, and there's a coil connected to this armature, and as the magnetic flux in the coil changes, then this head moves back and forth. And right now it's locked mechanically, so if anything happens to the drive during transit, it's protected. But there's a lock mechanism that if we take that off there, now this armature should move freely. And that's all the movement that it has for the hard drive. And like I said, that armature moves based on the electric field that is generated inside that coil by the control circuitry. The layout on the drive is basically all the data is in what are called tracks that run in concentric circles around the hard drive here. And then each track is divided up into what are called sectors. And so each sector contains a piece of information and can be directly addressable by the computer through the controller. The controller takes care of all the layout of the tracks and the sectors, and that will vary from one hard drive to the other depending on the make and model. The computer doesn't have to worry about the individual tracks and sectors. It just says I need data off the drive at this particular location, and the controller will figure out where that is physically on the drive. So let's start taking this apart. That screw holds in the ribbon cable. And there's a screw here that holds on this top magnet. That should just lift off now. You can see it, that magnetic field is really strong. It doesn't want to let me pull that out. There we go. And now we have a better view of that coil inside there. very similar to a voice coil in a microphone. These are just these are just mechanical parts. That's just a mechanical part of the parking mechanism. Another part of the parking mechanism. We've got some Torx screws that hold those in. Now this whole assembly should just lift straight out. There's one platter. There's another platter. And here we have the motor. This is typically a brushless motor that is built into the chassis. If you want to use this motor by itself, you really have to just cut it out of the chassis and figure out a mounting mechanism for it. It does have, in this particular case, electrical connectors back here. You cannot just connect power to this. You have to provide certain types of signals to that in order to drive the motor around. So it does require a brushless motor controller. And the final magnetic plate right there. If I can get it off. And there's the stripped down chassis. Okay, here's all the parts that make up a hard drive in this particular case. And like I said earlier, most of these drives, even the modern ones, all have essentially the same type of materials in them. First of all, there's the main chassis. It's usually out of aluminum or titanium or some sort of lightweight metal like that. It usually has the motor that's built into it. It's part of the chassis, pressed in. Usually you have to, it's got the bearings here, and yeah, you can't, if you want to use the motor, you need to cut it out of the chassis. You can't use the motor standalone. Cover plate that goes over the top of this assembly. And inside, then we have the platters that make up the recording medium. We've got some sort of connector, usually a ribbon cable like this, that connects the outside electronic controller board right here to all the internal electronics. This happens to have a little sound absorbing material between the controller board and the chassis to absorb any vibrations. A couple bushings that act as spacers for the motor and in between the platters. We have the read-write assembly with the coil mechanism on it and the read-write heads. We have two rare earth magnets that provide a magnetic field that the coil operates within. A couple miscellaneous plastic parts and a pile of screws and one nut. So that's pretty much it. Now you've seen basically what's inside every hard drive that I've ever torn apart. So as far as useful things for other projects, some people use these platters for clocks. That's one thing I've seen people use them for. It seems like I've seen a couple other projects using these platters for miscellaneous things, but I don't remember what they are off the top of my head. Clocks are the biggest thing that I've seen. Motors can be useful if you can figure out how to control them. Like I said earlier, they are brushless motors, and so you can't just apply power. You have to drive them with special brushless controller circuits. The head assemblies and the coil assemblies really aren't useful for anything. The electronics on the control boards are all proprietary, so there's not much useful there. You might be able to get a connector or two off of it. Another thing that can be scavenged out of these is the chassis. You've got some aluminum here that could be melted down if you have the facilities to do that. And you've got some metal plate here that you could cut up and use for different projects if you need small pieces of sheet metal. The biggest thing that most people get out of hard drives are the magnets. The rare earth magnets, super strong. They can be used for any kind of application that you'd want a magnet for. But first of all, we need to take them off of these backer plates. So let's go see how to take those magnets off the mounting plates. Okay, I have my vise temporarily mounted to my workbench, and the magnet with its backing plate is clamped in the vise. This backing material has an interesting property that it acts as a magnetic shield. If you see it, the magnets really don't attract each other at all this way. But if you put them the other way around, I'm going to do this with my fingers out of the way, they will attract each other with great force. It's pretty tough to pull that apart. And so that's kind of interesting. I'm not quite sure what this metal is made out of, but it does act as a magnetic shield. But it is very, very soft. It's thick, but very soft. And the magnets are usually just glued to this material. And usually you can just bend this material and the magnets will just pop right off, because the magnets don't bend with it. It just peels right off. And there's one magnet ready for use in a project. Let's pull the other one off. And now this becomes brass. This one's a little harder because it has these angles on them, but we'll figure something out here. Just put it down flat this way and peel upwards. And there's that magnet. And like I said, you need to be careful. They will cause blood blisters if they snap together with your fingers in between them. Scrap. Here's a hard drive that's vintage 1984. It's laid out essentially the same way. You've got platters here that spin around. You've got an armature over here with 3 bright heads on it. It is laid out a little bit differently in that the motor is up here in the corner and it's connected by belts rather than being built into the chassis with the brushless motors, but it's essentially the same thing. There's connectors over here to connect to the computer, and the electronics are on the back. Very similar in layout to the current modern hard drives. Hit like if you enjoyed this video and want to see more what's inside types of videos. Over here there's more computer related videos if you're interested in that, and down here there's a video that YouTube thinks you'd enjoy. Thanks for joining me on this creative journey that we're on, and until next time, go make something. Perfection's not required, fun is.